Hey, and welcome to 8.3. 8.3 is going to be creating the unit circle from the triangles that we've been working with. I've decided to change things up just a tad, and we're going to be doing an animation. I don't want to tell you how long I've been working this animation because it's been taking it's been a hot minute. But I think visually you'll appreciate it because you'll see what exactly we're doing. So let's go ahead and let's spin over to the animation. Okay, so here we go. This is going to be creating the unit circle with special triangles. Like I said, visually, I think this should help you get through a lot of things. So we're going to start with both an X and a Y axis, and we're going to create tick marks all the way around at a radius of 1. So the idea is the unit circle always has a radius of 1. Now, if we take that radius and we spin it around, we're going to create ourselves a circle. And the whole idea of a unit circle is, yay, I made a circle of a radius of 1, but what does this have to do with triangles? Well, let's say I pick a point on the circle. Let's say right there. Now, what is the coordinate of that point? Well, we know the distance to that point from the origin is 1 because if we spin the radius up, we have 1. Now, that coordinate has two different aspects. It has an x aspect and a y aspect. So you could almost say that if we have a radius of 1, we have a triangle right there. The vertical part of the triangle being the y and the horizontal part of the triangle being the x. So we can do that anywhere on the triangle. I can take a series of points and make triangles all over the place. It doesn't matter where, it doesn't matter what orientation the triangles are in, I can create those triangles. And if I connect all those endpoints, I've created the unit circle. So all of those triangles have a hypotenuse equal to 1, which is the radius of my circle. And I want to find the coordinates on this circle. So let's go ahead and let's start out with one of our basic triangles. Let's start out with one of the ones that is a 45, 45, 90 triangle. Now, if you remember from the other day, remember that it has side lengths of 1, 1, and square root of 2. Now, we talked about the fact that our unit circle has a radius of 1, so the hypotenuse has to be equal to 1. So how are we going to convert that? Well, how do I switch a square root of 2 into a 1? Well, I can divide it by itself. And so if I divide the square root of 2 by square root of 2, I have to divide everything by the square root of 2. And then I'm going to go ahead and I'm going to reduce, which means that that turns into a 1 and I can't simplify the other 2. Now I'm going to copy that down here because I'm going to be using that triangle. You see our original up there. And I'm going to be moving that triangle all over the circle. I'm going to move it over there. I'm going to flip it, rotate it, and rotate it. So you can see that all 4 of these triangles are our original triangle, and it's going to give us 4 sets of coordinates on our circle by using the side lengths. If I take those side lengths and put them on the first triangle, I can put them on the second triangle, but the y, this case, has to be negative. So again, from what we talked about the other day with negative side lengths, and I can put them on the other 2. Now, all we've done is we've taken a triangle and we've laid it down. Now, how do we find coordinates from that? Well, I can take each of those side lengths and create a coordinate. And 4. So I've got 4 coordinates right there. And this is, in essence, all the unit circle is about finding these coordinates, and these are things that we can use. So let's get rid of the triangles. And basically, we've got these 4 angles right here. We know the coordinates of those 4 angles. Let's take one of our other triangles, a 30, 60, 90, which has side lengths of 1, 2, and square root of 3. Again, I know my hypotenuse needs to be equal to 1. So how do I get that 2 equal to a 1? Well, I divide it by 2, which means I divide everything by 2. And I reduce it. I'm going to copy this triangle down. And then what I'm going to do is I'm going to move this over. Flip it there. Do the same thing what I did earlier. Rotate it so I get it on all aspects of the circle. Copy down my x and my y's. Pop them on there. And then I do the exact same thing. I move them and I create a new set of coordinates. Flip it around. And I can create another set of coordinates. So you see, with 2 sets of triangles, I've created a plethora of coordinates here. In fact, you can even say so let's not forget about the 4 radiuses, or the 4 radii, around the circle. we have our 1, 0, 0, 1, negative 1, 0, and 0, negative 1. These are 4 additional points that we can include in the circle. And now, realistically, all we've done is we've overlaid 2 different triangles on top of a circle to give us some coordinates. And these coordinates will be useful in the next section when we start identifying our basic trig functions and when we start graphing this over a distance of time instead of looping around itself in a circular fashion. Like if we work our way up from there, we're going to hit each of these degrees. And so tomorrow what we're going to do is we're going to convert these degrees to a unit of measurement that we can graph. But that is in essence the unit circle. I just wanted this to be a quick introductory video. Tomorrow we'll actually work on some problems using this information. But what I would do is I would copy this down somewhere because this is going to be very handy over the next few days. Okay, and that concludes the unit circle. I hope that was enjoyable, and I really hope that animation was worth the time to see how the graph is laid out. I'll see you tomorrow with some problems. And remember, if you have any questions, make sure to let me know.